So a few months ago, I wrote a blog post about generating a Rust client library for ZIO HTTP endpoints. And soon after it was published, somebody asked, why not OpenAPI? Why did I decide to directly generate Rust code from ZIO HTTP and not use OpenAPI instead? And that's a completely valid question. OpenAPI is useful, a lot of things supporting it. It's a standard to describe or specify APIs. On the other hand, I believe that using it for generating clients can be really painful. And I would like to show you that sometimes there is a possibility to do something different. But before that, I would like to share 3 different stories of myself trying to use OpenAPI to generate clients. And the first one was about almost 9 years ago when I was working for Prezi. And we had a lot of different microservices. They were mostly implemented in Python, and we were writing new Scala services at the time. And at least everybody agreed to use OpenAPI, or it was called Swagger back then, to document or services APIs. So we had this thing that was called Prezi Scala Tech Stack. It was a couple of libraries built on Akka, dealing with authorization, rate limiting, service-to-service communication, logging, AWS stuff, monitoring, and so on. And as part of this tech stack, I was trying to write a client code generator for OpenAPI. And back then, there was not many options to do that, so there was no guardrail library yet, for example. So I decided to use the official thing that was called Swagger code jump. And I did it. I created new templates that were using our set of libraries, our way of writing Scala. And in the end, it looked like something like this. And it worked. I think it's still working. I don't know. But it is a nightmare to maintain this. I don't want to see this ever again. And some other problems that I've seen was these specifications, at least the ones coming from the Python services, were many times partial in a way that, for example, they specified all the endpoints, but then didn't specify the actual response types or just parts of them. Sometimes they were just outdated, like they wrote it and then forgot to update it later when they modified the service itself. And the third problem that I've seen a lot there was the complete mess up of required versus optional fields. It was never specified correctly. So my learnings from this attempt of working with OpenAPI at Prezi, first is don't use Swagger code jump. But more importantly, that the specification and the code must be connected in one way or the other. And it can be in the way that you are generating code from the specification, or you can generate the specification from the code. But if it's like with the Python services at Prezi, where back then that there is no connection between the two, then it will go out of sync immediately after you create them. And the third one that is a bit surprising for me, that it seems to me that people with a weaker type system like Python I tend to write weaker specifications as well, like if you don't have to think about whether something is optional or not, because everything is always just optional, then you forget to specify that it's required in your OpenAPI specs. I don't know why it's like that, but that's what I see. So, second story is about ZIO Kubernetes, which I created while I was working with Coralogix a few years ago. And as you probably all know, Kubernetes is built on this concept of resources. Deployment is a resource, and pods are config maps, jobs, everything is a resource in Kubernetes. And it specifies this common set of operations for all the resources, like you can get them, you can create new ones, you can update them, you can delete them, and so on. So if you just imagine how you would start writing an idiomatic ZIO Scala library for working with Kubernetes, you would probably start with something like generic interface that captures this concept of each resource have a get and a create and so on method. And then you would use this generic interface to define different services, let's say using zlayer for each of these resources, and you would also write tons of different data types for describing these resources. So let's see what happens if we just take Kubernetes' OpenAPI specs, which is publicly available in some. My voice? No? OK. So if I just run in that huge Kubernetes OpenAPI YAML through one of the general purpose client generators, and we take a look at the generated data models, they are looking quite similar to what I just shown. OK, the class names are a bit weird, but that's probably easy to customize. I didn't try. There are these two extra fields that is a bit unexpected. And if we check what these are actually fixed string values. The API version is always v1 in this case, and the kind is always pod. And these two things are already described in the name of the case class as well. So I'm not that happy that they are appearing in the generated data model, but OK, otherwise this is good enough. I could start writing a library on top of this. But if we check how the generated client code itself looks like, it's a client class, and it contains all the operations of all the resources that Kubernetes supports in any of its namespaces and categories. Also, it has some weird things like this pretty and dry run parameters are options of string, which is a little bit weird to me. But the worst part of it is that this file is 30,000 lines long, and it's just a huge mix of everything in a single class. So let's see why is that like that. So about the lack of structure, if we take a look at the Kubernetes OpenAPI specification, it's full of this custom fields. Each model and each endpoint is annotated with this X Kubernetes group version kind, which associates these three coordinates of a group version and a kind with each of these specifications. But this is a Kubernetes-specific metadata, which the general purpose code generator doesn't know anything about, at least by default, without customizing it. If we take a look at those two option of string parameters, which are weird, they are indeed defined as a string, and they are option fields, or query parameters, I know. But if you take a look at the description of them, it says the valid values are all, and that's the only single possible valid value for this string. So I'm not sure the best representation for them is being an option string, but there is no way the code generator can use this information because it's only in the documentation comment. And just a side note that even in the Kubernetes OpenAPI specs, the option versus required annotations were not correct. So I had to introduce these overrides based on actual testing of the library. But the learnings for me from this attempt, that some rules just cannot be expressed with OpenAPI, for example, or at least hard. For example, that those fixed strings which are just attached metadata to the model JSONs, which are not really part of the domain model. And that people are using custom solutions for structuring the API, in this case, this X Kubernetes group version kind fields. And that sometimes people are I don't know, only specifying the actual type in the description instead of specifying the actual type. OK, so third story is about ZIO OpenAI, and I will start confusing OpenAI and OpenAPI starting from now. Sorry. the goal here was to create an ergonomic ZIO library that is generated from OpenAI's OpenAPI specification, which is available in a public repo. And so that was the goal, but I also had this secondary goal that I wanted this to be a prototype of a new ZIO HTTP focused client code generator, which I was hoping to be able to create something that creates a more ergonomic thing than using one of the general purpose ones, just because it has to focus only on ZIO HTTP. That was supposed to be just a side effect, and the goal was to create something good for OpenAI. You probably noticed that this is not was never released, so this side effect didn't really happen. So let's see what difficulties I ran into. So with OpenAI, first they are using YAML aliases to reduce the redundancy in the specification. For example, this image size is used in multiple places in the YAML, but it's not moved into its separate OpenAPI data type. It's just using this YAML alias thing to reduce, to only specify it once. But once you already parse this YAML, this is just redundant data. So I had to introduce this functionality that tries to unify every type in every place in the model that has the same structure and unify them as top-level types. Then they are using this pattern a lot, that any of, and then this type string and the type string, which is an enum, which is, if you think about it, it's what they wanted to say with this is that you can either pass a custom string or you can choose from one of the predefined ones. But here, this name custom and predefined are not in the specs at all. It is something that my code generator associates with this pattern, which is a good choice for OpenAI, but probably not a good enough or generic enough pattern for every case. Similarly, this one here, if you send a prompt to OpenAI, you can send a string, or you can send an array of strings, or an array of integers, or a nested array of integers. I don't know what that could be. But once again, these are all anonymous cases and inner types without any name associated with them. So what I'm doing is I'm using the inner type to figure out the name for all these cases, like an array of integers and stuff like that. But this is, once again, probably not a good enough general solution for every specification in the world. And about the structuring of the API, here they were also using a custom field called XOAI meta first. Recently, it was changed to use tags for the grouping, which is much better because at least that's not vendor specific. Then they were using this thing that they are specifying that a field is a type of object, but without any known fields, which really means that you can pass an arbitrary JSON into that field, which is okay. But in the documentation, they were actually listing at least 4 different fields, which are always available for this particular field. It was just not part of the OpenAPI spec. So I introduced this hard-coded set of fields and checking if it's a hyperparams field which is a child of the fine-tune object, and then adding them to this generated class. And one other thing which is even worse is some operations have this Boolean parameter called stream, which is a query parameter. And basically the description says that if you set this Boolean to true, then your endpoint's response type will be something completely different than what is in the specs, which is not that easy to automatically figure out from the OpenAPI specs. And finally, again, the optional and required flags were not matching here as well. So my learnings from this one is it's very hard to create a client code generator that is really general purpose. And the reason is that, in my opinion, OpenAPI is just too flexible to do that. too flexible to map it back properly to a well-structured, statically typed Scala code. So let's talk about ZIO HTTP. ZIO HTTP introduced in the recent versions this thing that is called Endpoint API. And Endpoint API looks like this. You are using this Scala DSL to define the get worker metadata endpoint here, which is a get endpoint with this path, and the path has some placeholders. It requires a header, an authorization header. It defines what kind of errors or successful responses it can produce. And you can even use your own domain types in these placeholders. For example, template ID is a path segment that is getting parsed to an actual template ID type. The response types can be arbitrary Scala types, and the only requirement is that you have to provide a ZIO schema value implicitly associated with these types, which you can derive with the derive schema macro. And once you have these endpoint definitions, you can, for example, implement the request handler that takes all these inputs that are appearing as placeholders in the DSL, template ID, worker name, and the authorization header. And you are just writing a function from these input parameters to a ZIO effect that produces the output worker metadata. You can also use the same endpoint definition to use it as a client. If you provide these three parameters to the apply method, then it behaves as a client that calls a remote endpoint. And yeah, that's the apply method. And then you can also generate OpenAPI specs from this, which is a new feature in the recent version, from the same endpoint definition. And if we take a look at all these endpoint and schema types, it's quite a complicated type. It encodes the inputs and the error type and the response type as type parameters. And but the point is that these are just Scala data types describing endpoints and data models, and you can do whatever you want with them, as you already seen in previous talks. So you can implement the server. You can use it to call the server. You can generate even OpenAPI from them. But my main point is that you can do whatever you want to do with them. And let me show an example of that. And this is this ZIO HTTP Rust project. It's a small library that I created as part of the Golem project. Because we had about 100 different ZIO HTTP endpoints written in Scala with ZIO HTTP that we wanted to call from our new Rust CLI tool. And so basically, we had to generate from these ZIO HTTP endpoints some kind of Rust code that is compiled to a client grade that then the CLI can use to communicate with the Golem Rust API. And so one part of this is that for every data type that is used on this API, we had to generate a corresponding Rust code. For example, for this case class worker metadata, we had to generate a Rust structure, which is almost the same thing with some different naming conventions, but that's it. And as I said, for every type that is used in ZIO HTTP endpoints, you have to have a ZIO schema value associated with it. And if we take this schema value, and for example, for the worker metadata, we just pattern match on the schema, we will find that it is a schema.record. And if it is a record, then we can look at its fields and just recursively process each of the fields, because each of the fields are also having their schema available in this ZIO schema, tree of schemas. And you are just traversing this tree and generating whatever you need from it. Here we are generating this Rust definition.field, which is just an intermediate representation that can be later pretty printed into Rust code. And similarly for endpoints, as this is the same get worker metadata endpoint value that I already shown. And we want to generate some Rust code from this, which is basically an asynchronous function taking all the inputs of this endpoint and then constructing a request in its implementation, calling the endpoint and parsing the response and returning it in some way. And as I said, the endpoint is also just a Scala value that you can observe. So here we have to basically observe three different parts of the endpoint: the input, the output, and the error fields of it. And all the three has the same base type called HTTP codec, which is quite a complicated type. It can, in case of an input, it can describe the request body. It can describe things like optionality or alternative different values in some place. It can describe required headers. It can describe the method of your endpoint, the path, and the query parts of it. It can contain transformations, so you can introduce your own data types into your endpoints, like I shown with the template ID. And you can combine all these. So in the end, you have one top-level HTTP codec, which you can get from the endpoint.input. And you just have to traverse all these different cases and figure out what to generate from it. And similar for output, it's the same data type with slightly different meaning. Here, the content means that the response body has this specific type. You can have outgoing headers. You can here have a status code associated with the request, but it's almost the same thing. And I don't really have time to get into details, but if you read this blog post, it describes in much more detail how this transformation of ZIO Schema and ZIO HTTP can be implemented directly with the Scala types. And finally, a conclusion. I believe that OpenAPI is too flexible. At least it is too flexible to be a good fit for generating strongly typed clients from it. It's just have too many corner cases and lack of names and so on. And because of that, I recommend that if you can, you specify your API with a strongly typed DSL in your code. And then ZIO Schema and ZIO HTTP is a good fit for that. And then I still recommend to generate OpenAPI from it because that's a standard, that is something that is supported by everybody. But if you, so you can think about whether you can use this schema and endpoint definitions to directly generate what you need instead of first encoding it in OpenAPI and losing a lot of details in the process. So thank you for listening.